Fun question being shape that looks like this. Let's label some points. P, M, R, and then you also know
B.
a few. A B, you want to call it B?
What is B?
B. So you know, this tells you that BR is what? The distance from B to R? 1,500. It told you the distance from P to B was 500. And it also labels this angle as theta. What's the first question asks you to do? Yeah, so if your path is this, so for A here, the time is going to be each distance divided by each rate. So what's your first distance on pavement? 1,500. Second distance is, and you're dividing by your rates, it's 300 here, and it's, so you end up with 10 minutes, right? So that means it takes you 10 minutes. Part B asks you if you go straight to the water and then over, so you're on the sand for how long? Isn't that what part B is? So you go straight out and then over. So how many feet are you on the sand for? 2,000. You're not on the pavement for anything. So it takes you 20 minutes. So that's basically two outer edges that you could think about. All of the other paths, all of the other reasonable paths have a theta value in between. What is the theta value if you moved M all the way over to B? What does theta become? Nope. 90. So in this case, theta is 90 degrees. In this case, the case they're talking about right here, they're talking about this case. That's kind of outside of the logic of the question, because the theta value, it's a much more direct route going like that, correct? Yes. If you're going to stay on the sand the entire time. But they just wanted to give you another thing to think about. So in the basis of reality, all of your paths should be between about maybe around 10 minutes or around 20 minutes. So if you have an answer like 6 hours is outside the bounds of reality, yeah, you always want to do that reality check. So part C, which is the guts of this entire question, asks you what happens, what is the time traveled just in terms of theta, just in terms of theta. The key to all of these, what did we know? We knew 300 and 100. What's the only thing that changes? There are two values that change. X. We haven't labeled an X. Stop saying, you guys like to say X. All my other classes like to say X.
BM was labeled as X.
Oh, okay. Yeah, on the sheet. I'm sorry, yes. But these distances, right? Those are the things that change when theta changes. Does the rate change?
No.
It stays the same. So we need to write those distances just in terms of theta. Which one do you want to find first, PM or MR? PM? What trig function could we use? Yeah, sine of theta is going to be PB. Sorry, what is it going to be? Well, it's PB over what? PM. Yeah, I gotta choose letters that not only look different but also sound different. What do we know in there? We know what PB is, which is 500 over PM. So we now know that PM is equal to 500 over sine theta. So now we have PM, which is half of it, or whatever fraction you want to say. Now we need MR. MR, what's the entire length of the pavement? 1,500. So what's one way to come up with the distance from M to R? 1,500 minus BM. So now we just need to find the distance from B to M in terms of theta. What trig function should we use? We could use cosine, but even cleaner, use tangent. Let's get that 500 again. So we now know that tangent of theta is equal to 500 over BM, right? 500 over BM. So we can solve for BM now. BM is going to be exactly. So now do we have the two distances? Yeah, so our time in terms of theta is now going to be PM 5. Oop, that's an interesting. Did you see what happened there? No, you didn't. 500 over. Sorry. 500 over tan theta is our first distance, and our other distance was 500 over sine theta. Oh, excuse me. This is BM, but what did we say? We need to plug it back in. We forgot to do that. Sorry, guys. So, yeah, minus that, right? we forgot about a key thing here. So we didn't want BM, we wanted MR. So what does MR equal? Yeah. It looks ugly, but it simplifies rather well. So this is not that. It is 1500 minus 500 over tan theta. Now this right here is the distance on pavement. So what's the rate there? 300, and the rate over here? 100. Let's clean this up a bit. Turns into 5 minus 5 over 3 tan theta plus sine theta. What can you factor out?
Wait, how did 500 become? Oh, 5/3, okay.
5/3. You got it. Yeah. Is that the 3? Yeah, what can we factor out?
5.
Yeah, I mean, you want to do this. The thing you have to watch out for, though, what do you have to do next for this question? And again, this is hindsight math. You don't see this until you do the next section, but you'd really want to simplify it. I mean, if it was me, this is how I would do it. I'd go 1 minus 1/3 cotangent theta plus cosecant theta, like that. What do you have to use for the next few questions, though? Your calculator. Did you actually read the next questions? Let's read what they say here. Calculate the time. Can you do tan inverse of 1/3 in your head?
No.
So what do you have to use? Calculator. So if you have to use your calculator, what's the futility in translating it to something that looks like this?
Just as many buttons.
What? Yeah, you can't put it in. When you type these into your calculator, you have to write everything in terms of sine, cosine, and tangent. Is there any direct cotangent button on your calculator? No, you always have to write 1 over tangent. So the thing that's the easiest to plug into your calculator is going to be this thing right here. Now for the part D, what does it ask you for part D? I think it just says, it gives you an angle measure, I think, right? Yeah, it says if you walk directly from the parking lot to the house, so in that case, what's theta? If you go directly, how do you figure out what this theta is right there?
It's going to be the inverse, tan inverse of 500 over 100.
1,500. You're exactly right. It's the tan inverse of that. So theta is going to be tan inverse of 1/3, and I think that's 18.435, something like that. It goes on. It's irrational. Store that, do it out. Now they want you to plug this into your formula, and then hopefully it comes out to the right thing. What's nice is I've already typed that in as y. Oh, he did not. He did, didn't he? Hold on, I got to type it out again.
I tried to figure it out with theta and got really confused.
Yeah, so listen. So just remember, you get to this and you play it out, but the last thing you should always keep in mind, everybody, 2 things. Check your work and make sure it matches reality. That's really, really important, that it matches reality. It's super important. Okay, so